Can you solve this algebra challenge? Here's the question. Solve for the real values of x and y given these two equations. 2 raised to the power of x plus y equals 6 raised to the power of y, and 3 raised to x equals 3 multiplied by 2 raised to the power of y plus 1. Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so our goal in this question is to solve for the real values of x and y that satisfies this equation. 2 raised to the power of x plus y equals 6 raised to the power of y, and 3 raised to x equals 3 multiplied by 2 raised to the power of y plus 1. Now, to answer this question, of course, let's use first the first equation. So we have 2 raised to the power of x plus y equals 6 raised to the power of y. Now, we will use some laws of exponent to answer this kind of question. So the first one is when we have b raised to the power of a plus c, it must be equal to b raised to the power of a multiplied by b raised to the power of c. Therefore, the expression on the left-hand side of our equation can be written as 2 raised to the power of x multiplied by 2 raised to the power of y. So using this identity. Now, what we're going to do is to divide both sides by 2 raised to the power of y. And then, what we're going to do is to use again some laws of exponent. Take note, when we have a raised to the power of c over b raised to the power of c, we have the same exponent but different base. It must be equal to a over b raised to the same power, c. Alright, so the right-hand side of our equation can be written as 6 over 2 raised to the power of y. Now, 6 divided by 2, this will give us 3. Therefore, we can say 2 raised to x equals 3 raised to the power of y. So, this is still our first equation. Now, to continue this, let's take the logarithm on both sides. So, we will use base 10. Now, let's use some laws of logarithm. If we have logarithm of b raised to the power of a, this can be written as a, we can put this exponent in the front, so we have a multiplied by logarithm of b. So, the left-hand side of our equation can be written as x multiplied by logarithm of 2, and the right-hand side of our equation can be written as y multiplied by logarithm of 3. Now, let's solve for the value of y in terms of x. To do that, let's divide both sides by logarithm of 3. So this is now the value of y. We have x multiplied by logarithm of 2 all over logarithm of 3. And also, we can rewrite this, we can simplify this because logarithm of 2 over logarithm of 3 is constant. So we can simplify this as x multiply this constant, logarithm of 2 over logarithm of 3. Now, let's continue. Let's take now the second equation. Alright. Now, first, let's divide both sides by 3. And then, let's use some laws of exponent. When we have b raised to the power of a over b raised to the power of c, we have the same base and different exponent. So, this can be written as b raised to the power of a minus c. Now, take note. 3 on this denominator have an exponent of 1. So, the left-hand side of our equation can be written as 3 raised to the power of x minus 1. Now, let's continue. Let's take again the logarithm of both sides, again, in base 10. And using again some properties of logarithm, we can put this exponent in the front, like this. We can do that also on the right-hand side of our equation. Next, what we're going to do here is to divide both sides by logarithm of 3. Now, we can separate this logarithm of 2 over logarithm of 3 because this term right here is just a constant. Alright, now what we're going to do is to distribute this constant to y and multiply this by 1. So, if we do that, we get something like y multiplied by logarithm of 2 over logarithm of 3 plus logarithm of 2 over logarithm of 3. Now, we are now ready to solve for the value of x. Why? Because we have now the value of y in terms of x. Because y must be equal to x multiplied by the logarithm of 2 over logarithm of 3. So we can substitute this y with its value like this. Now, we have now an equation in terms of x. But before we solve for the value of x, let's simplify first. Logarithm of 2 over logarithm of 3 multiplied by itself. So this can be simplified to logarithm of 2 over logarithm of 3 raised to the power of 2. Now, let's focus on this equation. And now, let's solve for the value of x. So, let's rearrange some terms a little bit. And then, what we're going to do here is to factor out this variable x. If we do that, we get x multiplied by 1 minus logarithm of 2 over logarithm of 3 raised to the power of 2. On the right-hand side, we have 1 plus logarithm of 2 over logarithm of 3. And take note, our goal is to solve for the value of x. So let's divide both sides by 1 minus logarithm of 2 over logarithm of 3 raised to the power of 2. Like this. Now, we know we have here 1 squared. So we have a square number minus another square number. So we can use the difference of 2 squared. If we have a squared minus b squared, this can be factored as a plus b multiplied by a minus b. So the denominator of our equation can be factored as follows. We have 1 plus logarithm of 2 over logarithm of 3. This is very familiar. And 1 minus logarithm of 2 over logarithm of 3. Now, we can now cancel out 1 plus logarithm of 2 over logarithm of 3 on the numerator, and we also have a factor in the denominator. So we can cancel both of them. This is just equal to 1. So, x must be equal to 1 over 1 minus logarithm of 2 over logarithm of 3. Now, to solve for the value of x, let's simplify first the denominator. So, this 1 can be written as logarithm of 3 over logarithm of 3. The reason is we need to have the same base, so we can now combine them. If we combine them, we have logarithm of 3 minus logarithm of 2 over logarithm of 3. Now, just take the reciprocal of this, and we get that the value of x must be equal to logarithm of 3 over logarithm of 3 minus logarithm of 2. We're not done yet because we will use some laws of logarithm. Take note, when we have logarithm of a minus logarithm of b, this can be written as logarithm of a over b. So our denominator can be simplified to logarithm of 3 over 2. And that is the value of x. Now, how about the value of y? So we know y equals x multiplied by logarithm of 2 over logarithm of 3. We know the value of x. This is just logarithm of 3 over logarithm of 3 over 2. Now, from here, we can now easily see that we can cancel out logarithm of 3 on the numerator and on the denominator. So, this simplifies to logarithm of 2 over logarithm of 3 over 2. And that is the value of y. But, again, we can simplify this further. Take note of this. Using change of base property, if you have logarithm of a over logarithm of b, this can be written as logarithm of a to the base of b. So, x must be equal to logarithm of 3 to the base of 3 over 2. And the value of y can be simplified to logarithm of 2 to the base of 3 over 2. And that is the only real solution to this equation. And as always, we are done.